So you've probably heard the word tokenmaxxing, which is burning insane amount of AI tokens because for some reason, people as well as companies started to believe that burning more and more tokens means being more productive. I mean, that's not the case. Well, there's an open source tool called Headroom that goes after the wasteful part of token maxing. And today I want to show you how to take advantage of that for some token anti-maxing. So if you look at my screen, what I'm doing here is I'm using Headroom and I have uploaded a file which is going to be around 500,000 tokens. And you can already see the estimated cost, which is 1.4852. And if I select another expensive model like Fable, and once Fable goes away, 4.8 Opus or any other expensive model, you can see the price here. So what I did was I asked a question, so summarize the key findings or main points from this document. Just for your reference, this is the document that I'm talking about. So this is a long document and these are sort of like the log files, right, that you would generally see. Now, if you ask a question like this is before and this is the after, right? So if I do not use Headroom, it is going to find those answers and it's going to use all of these tokens. But if I'm using the Headroom, it basically compresses this and you can see the reduction value is around 26%, right? And I've also verified the answer. So you can see the cost difference between using Headroom and without using Headroom. And imagine asking 20, 25, 50 questions just by one person. And if you imagine like if you have like a team of 20 people, you can imagine the cost multiplies quite a bit. And this is just a cost of one question, right? So that is what Headroom actually does. Now, this is a custom UI I built in order to explain this, but Headroom actually comes with a UI built, right? So this is where you can run this directly in Claude Code. So I ran this here and I said that read the sample massive text file in full and then tell me what caused the crash, right? So you can see how it responded here, right? So the crash was caused by an out of memory condition. The rest of the file is all 2,500 lines I felt and presumably thousands. Is this just a single repeated line? So this is a textbook example of needle in a haystack log file. So this is not something which I've done programmatically. I have simply used Headroom and it has come back with this answer, right? And this is the out of the box dashboard where it tells us that this is the dollar amount that you have saved. It gives you a lot of details around what is the impact from a prefix perspective, what is the hit rate and stuff like that. So in the demo, I'm going to go into much more details around how you can get something similar and how I build this. But I want to talk about token maxing for a minute, right? And why this Headroom and solutions like this matter a lot for anyone who is using large language models on a day-to-day basis. Now, this year, companies started treating token burn like a productivity score. Meta famously built an internal leaderboard. The top person hit 281 billion tokens in a month. Uber reportedly blew its entire 2026 AI budget by April. These are all reported stories, right? You can see the screenshots here. Now, the whole industry is swinging back. People are calling it token discipline. And look, you don't need a leaderboard to know the feeling. If you have run agents, you have watched that meter climb really high and wondered what it's even spending on. Here's the thing though, most of that burn is just waste, right? So it's not always someone trying to rig the system. Probably the agent reads the same file 3 times, 10,000 log lines of everything is fine. And that's what Headroom kills, right? So it's an open source compression layer started by an engineer at Netflix. It is now 55,000 plus stars, #1 on GitHub, and it's still trending. And it sits between your agent and the model, shredding the noise before it even gets sent. Reversibly, right? So the originals stay cached on your machine. So I'm going to do 2 demos. You already saw the teaser, my visualizer app. So you can actually see the compression happen and we will go into Claude Code and basically run the command and we will go through the same exercise and I'll populate the dashboard and you can see for yourself, right? And you will be able to repeat all of this yourself and start incorporating this in your day-to-day workflow, okay? So a disclaimer before we get there, all opinions are my own and do not belong to my employer, all right? And of course, this is not at all sponsored. I'm not affiliated with Headroom by any capacity and nobody's paying me to do this, all right? So with that, let's get into it. All right, so what you're seeing right now is the actual GitHub page of Headroom. I will obviously share the link in the description. And you can see that they claim that it reduces the tokens by 60 to 95%, which is pretty good. And it is content aware compressor. That means it is local first. The data doesn't leave your machine and it is reversible, right? So you do not lose data as well. And it has been trending in GitHub and it is #1 repository, right? Now, what you can see here is you have various ways to use this. So you can obviously use this as a library. It can be used inline in any app. So the first demo that you saw where I showed this compressor in an app that I built was using this as a library. Then it can also be used as an MCP server. It can be used as a proxy. And then you can also use this as an agent wrap. So you just give this command Headroom wrap the name of your agent, whether it is Claude, Codex, or whatever, right? So depending on whatever you're using. And then you can also unwrap it using this particular command, which is Headroom unwrap, the same tool, which is pretty cool. So this is how it works, pretty straightforward. Whatever is your agent or app, depending on how you're using it. If you're using it in lines, that is app or as a library. If you're using it within the agent, then you have the Headroom wrap, right? So it basically runs locally. This is super important because there's a bit of a confusion whether the data goes out, looks like it runs locally, and it compresses your input, right? So it compresses your input token. It doesn't play with your output. And then you basically get a compressed prompt. And then that compressed prompt is sent to the LLM provider. So imagine like you're asking the same question, which has to go with the same log as an input. If it can compress that log, then automatically you are saving the token, right? They also share the architecture here, which is pretty cool. So what I'm going to do here is I'm actually going to start with Claude Code and show you how you can exactly go ahead and use it in your day-to-day workflow whenever you're working with Claude Code. Okay, so let's get into that. Okay, so the first thing that you need to do is obviously to install Headroom. So that is the command that you will give. And then once it is installed, then because I'm going to be using directly in Claude Code, I'm going to write Headroom wrap Claude, right? And went through that in the GitHub description as well. So the idea here is Headroom is now started a local proxy. We can see the port number here and then pointed Claude Code to that proxy, right? So everything now flows through the compressor on my machine. And that is what you saw in the architecture as well. So now you can see that Claude Code is here. And now this is how I would talk to Claude as I usually would, right? So now I'm going to ask this particular question, which is, hey, read the samples massive logs.txt and then give me the answer where the crash was caused, right? So just for the reference, this is the massive log text file, which is really large, and it needs to find where the crash happened. So you can see here, this is the answer. So, it's going through this and it is understanding that, hey, there's a lot of tokens that is going to be wasted. So it is already compressing. This is all coming from Headroom before it sends that to Claude, right? So it is going to try to compress this ahead of time and then only send the relevant stuff, because what I've asked it is like, what caused the crash, right? So now Claude Code, as expected, has given us the answer that the error happened, the crash event happened at this particular line, and the details around it, right? It's explaining what has happened, right? So that's the idea. Claude Code is behaving the way it should behave. So now in order to see the dashboard, all we have to do is type Headroom dashboard in PowerShell, and it immediately opens up the dashboard, right? And you can see the total amount of dollars that we have saved. And this is after multiple runs, because I was also preparing for this demo. And you can see all his history, right? These are the models that we have run. This is the input tokens saved. So you can see the amount of token, and that is how it is translating to the dollar value, right? And you would also see the before and after, the token flow and stuff like that, savings breakdown. So it's very detailed, the output that directly comes out from Headroom, and you should be able to see saved by compression. So you can already start to understand, if you continue to use this in your normal day-to-day conversation, especially when you're dealing with logs and stuff like that, I think over time, it's just going to keep increasing, right? Right now, the dollar value looks very small, but imagine if you're working with heavy databases and let's say that there are multiple team members that are working, it should be able to really save you a lot of money. So that is what I wanted to show, which this is the out of the box possibility, right? Now, what we will also look at is an app that I used anti-gravity to build and basically cloned the Headroom repo, right? So you saw here from an architecture, from a GitHub perspective, they have mentioned that you can use this as a library as well. So that's exactly what I did. And here I basically uploaded this and I calculated the cost and I wanted it to show me the token, right? So you can see the answer verification as well, because you want to make sure that whatever you saw in Claude Code, the same answer you can see here, because this is a UI that I built. And this is basically running, you can see the under the hood section here. It is basically running the Python code here, right? So this is, if you're using a PDF, then it'll use a PDF document, but in this case, I'm just using the text file. But then that is a transformation that it has applied and the code principles remain the same. So you could go ahead and clone this repo and build a custom UI. That is exactly what I did. And I had to give the API credentials here from Anthropic and my project details because I also use Gemini. But you can see that you are able to use it for any particular model of your choice, right? So that's the idea. And you're seeing the before and after. So it ran live. So this is what I wanted to really share today, right? So if you use Claude Code on a daily basis, I feel that you could incorporate this and see if you're able to actually minimize the token specifically when you're doing like an input. They are promising like 60 to 90%, but you can see that I only saw 26%. But of course, I just ran one or two examples just to prepare for the demo. This is not like a dedicated development environment. So I'm assuming as larger the context becomes, maybe it will actually compress it much more. So would love to understand if you plan to use something like this, and if you have actually successfully used it, what is the compression ratio that you got, right? And was this actually helpful? So let me know in the comment section what you think about this. I hope this added some value to you. If it did, please hit that like button. And if you're new here, please hit subscribe button so that you can keep getting videos like this. All right. Thank you very much for your time. Thank you for watching, and I will see you in the next one.